Hello everyone and welcome. My name is Eric Coleman with IIST and I will be the moderator for today's webinar. It's not too late to measure, analyze, predict, and manage release quality even late in the testing cycle by Mike Ennis. We're excited you're able to join us today. Set aside an hour to attend this webinar. This webinar is one of a series of free webinars to introduce the topics as well as the presenters of the upcoming PSQT conference in San Diego, California, August 14th through the 19th at the Sheraton San Diego Hotel and Marina. PSQT is the only conference that focuses on practical best practices in every aspect of software quality assurance and testing. The ongoing theme of the conference, Practical, Proven, Feasible, keeps the focus on what works. To learn more about this exciting conference, visit www.psqtconference.com. You may submit your questions at any time during this presentation by using your question box in your GoToWebinar window. Today's presenter will answer as many questions within the time allowed at the end of today's session. This webinar is being recorded and will be made available for viewing within 48 hours at psqtconference.com. At the end of today's webinar, you will be asked to complete a short survey. At IIST, we strive to provide the highest quality educational resources for the public and would appreciate it if you could take a few minutes to complete this short survey. I will now turn the webinar over to today's presenter, Mike Ennis. Mike?
All right, welcome everyone. Hopefully you can hear me better. I look forward to talking to you about this topic today. As Eric mentioned, the title is called It's Not Too Late to Measure, Analyze, Predict, and Manage Release Quality Even Late in the test cycle. I'm confident by the end of the webinar you'll get a good understanding of what the topic is and really how it can be a benefit to you. Some objectives for this webinar as we continue to talk. We want to understand what's the ongoing problem with providing quality understanding as we get closer to the end game of a software project. And that's really what this is about. We're understanding what are some of the key metrics and how can we mitigate, manage risk as we are getting to the end of our test cycles and we are in a position where we are making decisions about the quality level of the product that's under test. So we'll understand some test metrics in terms of how we approach this throughout the project. We'll also identify and measure what those key metrics are that really provide these quality indicators. We'll learn how to graphically represent the metrics more effectively. We'll learn how to analyze, predict, and manage the software testing as the project gets closer to the end. And we'll also identify what tools are going to be needed in order to enhance the metrics gathering and reporting. Who's going to benefit from this webinar? If you're a QA manager, QA lead, project manager, program managers, development leads, development managers, you might be a Scrum coach, master, anyone that's in a position where you are reporting test status is going to benefit from this webinar. So let's talk about getting back to the problem statement, and I call it, are we there yet? You know, in many cases, as a QA lead or QA manager, as you get to the last few weeks before the end of the test cycle, you know, we're always asked, are we ready yet? Are we ready yet? How's the quality of the application doing? What are the risks involved now? Are we ready to ship yet? So that's normally a lot of times what we're asked from a quality perspective. And usually when we're asked that question, we're going to pull from several mental models in terms of being able to quantify that answer. You know, we might look at, so what's our exit criteria? You know, is the application meeting that exit criteria? Are there some quality metrics that we've got in mind that are making that decision for us? Have we completed our test plan? You know, in some cases, that's when you know when to stop testing. Do you have a customer commitment? Meaning you may not have completed your testing, but you've got a customer commitment in mind, in hand, that you've got to adhere to. Are your release dates preset? You know, meaning, you know, we're going to test up until a certain point, but we've got release dates that are set and got to release to. Or you're engaging in indefinite testing until you meet certain criteria. Do you have adequate test coverage? And we'll talk about that later. Have you achieved that goal? And then obviously, time, budget, and resources might be a factor there. So you can see there are lots of things that factor in terms of when do we stop testing? Are we ready to ship yet? What are the outstanding risks associated with it? The first thing I want to talk about is, is your exit criteria meeting your needs? In many cases, we use a lot of quantitative criteria. Here are some exit criteria that I've used in the past. Have all of your test cases been executed 100%? Do you have 100% requirements coverage? No severity 1 or severity 2 defects, which are your showstoppers, high or critical defects. Minimal severity 3 and severity 4 defects are still outstanding. The product must run consecutively for 72 hours without system degradation. All of your predefined performance criteria has been met. The product meets all of the necessary usability and accessibility standards. This is just an example of some of the exit criteria that I've used in the past. But I found, is this sufficient? Is this sufficient for really determining whether a product is ready to ship or not? I found that in many cases we can use these as guidelines, but they really don't help us analyze and predict the actual risk that's in the application. But definitely, I'm sure most of you have seen these as part of your typical exit criteria. You might have some qualitative, criteria, which are more subjective. The business users, they may need to certify the product is fit for use. Is the product user-friendly? Your business users like the look and feel of a product. It has nothing to do with functionality. Does it flow right? Does it logically flow and thoughtfully in terms of the number of optimal steps in order to execute a particular business process? Or it could be everyone likes it. I'm just giving you some examples. I've been in consulting for over 25 years. I've seen lots of different criteria being used to determine whether a product is ready to ship or not. So you can see some are very specific, some are very generic, some are guidelines. But you can see how this can become a very interesting dilemma to have. For example, I'm going to give you a real-world scenario. Let's say you're testing a project, and here's the scenario. All of our tests have been executed. We've got 100% requirements coverage. We encounter one showstopper defect that crashes the application. All of our performance criteria have been met. All of our usability and accessibility standards have been met. The business users who have engaged in our user acceptance testing or our field testing, they absolutely love it. Do you ship? That's the question. Remember, everything on here sounds good with the exception of that showstopper defect that crashes the application. Do we have enough information to really determine whether we should ship or not? And in often cases, that answer is really no from a testing perspective, because one, we need some additional information. What percentage of customers are going to encounter that defect? Are there financial implications of this showstopper to the business? So there's some financial implications there. There might be some business continuity issues there around the percentage of customers or clients that this defect would affect. There's more information that's needed in order for us to really make an adequate decision in terms of where we ship. Meaning that this is just an example that we need more information, even though an application may seemingly meet most of our exit criteria. There's more information out there that's needed in order to quantify this. So let's get into measures and metrics, which is really the gist of this webinar. Just really quickly, just really defining what a metric is, and that's really the combination of two or more measures to provide meaningful information. And when two people look at this particular measure, they derive the same thing. There shouldn't be a difference of opinion in terms of that. Some different types of metrics that you typically would track. You might have their coverage assessments, requirements coverage, risk coverage, code coverage. You've got milestones that you can track as metrics. You've got testing costs, the cost to develop design tests, cost to execute tests, maintain tests, as well as the subjective confidence of testers in the product. Lots of different types of metrics. In terms of metrics by metric domain, there are really three key domains in which you can group metrics in. There are quality metrics, there's cycle time productivity, and then there's cost metrics. I won't drain all of these, but really I just wanted to, maybe we'll highlight just a few just to touch on some of our typical metrics that we would track from each domain. From a quality perspective, we might be looking at our artifact or test case passing percentage, defect removal effectiveness, defect arrival trend, requirements volatility. We might be looking at requirements coverage, test coverage, root cause, rework, or risk-based testing. From a cycle time or productivity perspective, we might be looking at the artifact development percentage or trend. What's the execution percentage? What's our defect aging? What's our fixed backlog, retest backlog, our defect closure trend? From a cost perspective, we might be looking at the cost of poor quality, the cost of quality. What's our test automation percentage or ROI? Are we adhering to our budget, etc.? So I just wanted to give you an overview of what are the typical domains of metrics that we could theoretically collect. The point is we can collect and track lots of different metrics, but really what do they mean? As start to collect metrics, there's lots of traditional reports that we could use those metrics as a part of. Some of the more common traditional reports are Pareto Charts, fishbone diagrams, histograms, run charts, and control limits. We'll run through those very quickly just to provide a brief education on what they are. So if you think about a Pareto chart, so the gist of a Pareto chart is really the 80-20 rule. 20% of the issues normally represent about 80% of the failures. So you can look at this example now, and you can see that if you look from right to left, you can see the first three categories are really contributing to about 80% of the issues, where unable to download, can't find the file, opens as read-only. Those are the three key issues that contribute more than 80% of the issues. So this is your typical Pareto chart, meaning the vital few comprise the majority of issues. The fishbone Ichikawa diagram. So this is a good report to use as you're trying to map out the possible causes for defects. And the way you would read this Ichikawa chart from really right to left. So you have a particular area of functionality that that has failed. In terms of the pink box, hopefully you can tell that that's a pink box, the functionality related defect. And then you can see the possible fish bones in terms of what caused that defect. Was it lack of knowledge? Was it, and there's some subcategories as well. Was it an external dependency? Was it knowledge transfer but not done properly? Was it unit testing not done properly? Was it new teams or new concept? And then lastly, requirements not clear. So this is a good form of root cause analysis to tie back the key issues for why a defect was found in the first place. I really like the Ichikawa diagram in terms of root cause. Then we got our histogram. So you've got your histograms, which these are going to distribute your defects into various groups. And you can see basics, some grouping here on your left-hand side. You've got your grouping of defects, severity 1, severity 2, severity 3, severity 4, in terms of, and then you've got the number of defects associated with each of those severity levels. That's one way of the defect distribution by severity level. On the right-hand side of it, you can also look at it in terms of defect distribution by days open. So if we were reading this diagram, you could see, between, you've got almost 30 defects that have been open 1 to 7 days. You've got about 18 defects that have been open between 8 and 14 days. So just some defect aging. You can also do your defect aging by severity as well. Lots of different ways to skin the cat. Run charts are very popular. I like to use run charts. So this shows metrics, graph defects over time. So in this instance, you can see we're looking at your defect arrival rate, defect closure rate, and your total number of defects. Your total number of defects would be represented in your red line going across the top from week to week or day to day, and then your green line is the total number of defects that have been closed, and then you've got your back line, the total number that are still outstanding. Then you've got your control charts, very similar to your run chart, but this is really showing or demonstrating your defects or processes within certain limits. So you can see we've got an upper limit at 70, we've got a lower limit at around 28. So this is saying which the number of defects or processes that are staying within these control limits. And if we look at this, we can see there were 2 points during testing where this process or defects exceeded the number of acceptable controls. You can see in, I believe that's maybe week 6 or something like that, or day 6, we reported about 80 defects. It was up to 80 defects, and then further down the line, we reported almost 80 defects as well. So these were, the purpose here is to really identify anomalies in your process. So there are some benefits for traditional testing. You get a good individual snapshot of quality. You can focus on root causes or what's most important, that 80-20 rule. Leveraging your root cause, you can look for areas for process improvement. Using that Ichikawa diagram, you can identify causes and effects of defects. Many of those charts give good indicators of quality issues very early on. You can also use them to look at to see if your quality is increasing or decreasing in your run charts around your defect arrival rates, as well as providing good information around defects or processes that surpass your accepted control limits using those control charts. So there's a lot of good benefits from how we traditionally report metrics. There's some limitations. One, as I mentioned, one of the benefits was it does provide a good individual snapshot of quality, but it doesn't provide a holistic view, meaning it doesn't pull many of those metrics together as one so that you can see how they affect each other. It doesn't show the relationships between the metrics. It limits the ability to assess risk. It limits our ability to predict what's going to happen in future weeks or future days of testing. It limits our ability to put the quality in proper perspective. It also limits our ability for the project team to define acceptable ranges for good versus bad quality, and we'll talk about that. We'll talk about that shortly. So getting back to the problem that I mentioned at the beginning of this webinar, when a tester or test lead is asked, are we ready to ship yet? Normally, a test lead has a certain set of metrics, or he may have his own dashboard in his mind, or things that he's collecting in order to make that determination. So he might be looking at what functionality is still to be tested, what percentage of tests are passing, how many resources are we consuming in order to execute those test cases, requirements coverage. Are we satisfying our requirements at an acceptable rate? Are any requirements changing? So this is getting to your requirements volatility. So these are just some typical things that might be on a typical tester's or test lead's dashboard. So now let's get into really how we're going to set up our test readiness charts for the analysis, prediction, and management. So the process really is we're going to select our metrics, we're going to select our ranges, then we're going to start to create our spider charts. The first step of this is deciding what to measure. I typically use, there's 6 key metrics that I have found to be very, very important in terms of measuring quality over time. They are code turmoil, defects found this week, total number of open defects, code coverage, test success percentage, and test completion percentage. And I'll give some brief definitions on this as we go through it. Code turmoil might be a new term for many of you guys, or you might have referred to it as code change. Code turmoil is the percentage of code that has changed from build to build or from sprint to sprint. Very important metric that shows it's a very good quality metric in terms of showing how much code is being changed from a developer's perspective as we are testing one build to the next. Defects found this week. So this is getting to our defect arrival rate. Again, a very good quality metric in terms of, are we finding more defects? Are we finding less defects? Is the arrival rate going down or going up? Total number of open defects. As you can see, this is very similar to defects found this week. So this is our defect aging. How many defects are still outstanding in the system? Code coverage. Code coverage is a new concept. Maybe not new to many folks, but it's still new to a lot of folks out there. This is the percentage of test cases that have been hit or executed by our test suite. We can spend a lot of time talking about that. You can also, for that metric, you can also use requirements coverage. Not quite as good, but requirements coverage kind of gives you a similar metric. Test success percentage or test passing percentage. This is the percentage of test cases that have passed. Test completion percentage. So this is the percentage of test cases that have been executed or completed. I call this my big six in terms of what are we going to measure as we start tracking our spider charts. If you have an Agile project, so how do those metrics relate to Agile? You can use many of those metrics that we just outlined on the previous slide. But for an Agile perspective, they can be based on your individual sprints or iterations. You can absolutely still use your test completion rate, your success rate. You might want to throw in your user story completion rate as one of those coverage metrics. And then also you might want to just start tracking or looking at the total number of open defects. So you might just want to just look at the number of open high severity defects. So let's talk about, so we've outlined those 6 metrics. Let's look at each metric and how they affect one or more metrics. So we can start, if we look at test success percentage or test success rate. So if you have a low test success percentage or rate, that's going to affect your test completion percentage and your code coverage. So what I mean by that is, if you've got a low percentage of test cases that are passing, that's going to affect your ability to continue to execute test cases. So that's going to affect your test completion rate. If you're unable to execute test cases, that's also going to affect your code coverage or your requirements coverage. If you have a low test completion rate, that affects every single other metric here. Because if you've got a low completion rate, that must mean that you've got a low test success rate, or your test success rate is not where it needs to be. That must mean, and if you've got a percentage of test cases that are failing, that will affect your total number of open defects, which is also going to affect your defect arrival rate. And whenever, excuse me, and whenever we are in the process of fixing or debugging or retesting defects, right there in the middle in red, that's code turmoil and code churn. So if you're unable to complete your test cases due to open defects, that's also affecting your code coverage rate. And as you can see on the bottom right-hand side, if you've got open defects, that's going to affect your code churn because developers are going to have to fix those defects. And then lastly, low coverage affects test completion. So if your coverage is low, then that should be affecting your ability to complete the number of tests that you had planned. The second part of creating the charts is we're going to set ranges for each metric. And these are just examples of some metrics that I've used in the past. And as you can see, we've got our metrics listed across the left. Let's not talk about our ratings for a minute. Let's focus on really the ranges. So as you can see, let's look at test completion percentage. Test completion percentage, we are setting up ranges for 6 to 1. 6 is good, 1 is bad, and we are setting up ranges for each of these metrics from high to low. So just running through a few of these. So we're going to give a 6 if you completed 100% to 95% of your test cases is a 6. 90 to 94% is a 5. 85% to 89% is a 4, 80% to 84% is a 3, 75% to 79% is a 2. Anything less than 74% completed is a 1. Let's talk about test success percentage. If 100% of our test cases are passing, that's a 6. If 97 to 99 are passing, that's a 5. If 94 to 96% are passing, that's a 4. 91 to 93 is a 3. 88 to 90 is a 2. Anything less than 87% of our test case passing is a 1. Let's look at the total number of open defects. If you've got 0 to 10 defects that are still open, that's a 6. 11 to 15 is a 5. 16 to 20 is a 4. 21 to 25 is a 3. 26 to 30 is a 2. Anything greater than 31 open defects is a 1. Keep in mind, these are examples, these are ranges that I have used for previous projects. As a part of this process, you will need to work with your development and project teams to determine what these ranges are. They should not be set just by the QA lead or the QA manager. This must be a team discussion and consensus, because you're going to be reporting on the status based on these ranges. Let's look at failure rate this cycle. So this is our arrival rate of defects. Your 6 is 0 to 2. 5 is between 3 and 4. 4 is between 5 and 6. 3 is 7 to 8. 2 is 9 to 10. And if you have found more than 11 defects in this cycle, that's a 1. Let's look at code churn. Remember, this is the percentage of code that has been changed from build to build. 0 to 10% is a 6. 11 to 15% is a 5. 16 to 20 is a 4. 21 to 25 is 3. 26 to 30% is a 2. Anything greater than 30% of the code that's been changed in this build is a 1. And then lastly, code coverage. If your code coverage has garnered 80 to 100% of lines of code, that's a 6. Between 70 and 79% is a 5. Between 60 and 69% is a 4. 50 to 59% is a 3. 40 to 49% is a 2. Anything less than 39% is a 1. Let's talk about a few other things on this chart. Your rating that you see here, this is going to be determined by what the actual raw data was for that particular cycle. That's going to determine your metric. And then we're going to total these metrics up. And then based on that total rating is going to determine whether the application is in a green status, meaning very low risk, yellow status, moderate risk, red, high risk. So as we are creating our test readiness chart, you can see that the top part of the chart has our metrics, rating, and ranges, which you can see from the previous slide. And then we have our raw data. So very important aspect here. So right now we are collecting metrics or data for week 6. So now this is 6 weeks, as you can see, this is a countdown. So we are approximately 6 weeks from the planned ship date. So now we start to track this metric at week 6. And here is the raw data is exactly where you are in that particular project. So our test completion is 75%. And based on 75%, let's go up to our ranges. Our 75% is a 2. Our test success percentage is 90. So let's go back up to our ranges. And the 2 is going to be 88 to 90%. So that's also going to be a 2. Total number of open defects. There are 20 open defects in the application right now. We're calling that application X. Let's go to our scale. That's going to be a 4. 16 to 20 is a 4. Failure rate this cycle, this is our defect arrival rate. So we found 10 defects this cycle. So based on our rating, that's a 2, 9, and 10. Our code churn, so in this particular build, approximately 50% of the build was changed. So let's go to our code churn range. We can see that greater than 30% is going to be a 1, so that's a 1. Our code coverage is 40%. So the test cases that we've run, we've actually executed 40% of the code. So based on our metric, that is going to be a 2. So as you can see, if we total up all of our metrics for this particular week 6, we're at 13. 13 translates to a red. So now we have our spider chart, which has been created based on our metrics. For each of these, you can see that we've got all of our 6 metrics plotted here in our spider chart, and we have plotted those ratings for each of those areas. The way you read this chart is, we've talked about 6 is good, 1 is bad. We want this entire spider chart to be filled up. That would mean that we would almost have a 6 in each of these areas. So as you can see at week 6, there is a tremendous amount of risk in our project in all of these areas. Really the only one in which we are moderately okay is going to be our total number of open defects. But you can see that there are huge areas for concern in all of those other areas due to where we are. So as we analyze the data, we're looking for the uncovered or the uncovered space symbolizes risk. We're looking for trends and patterns. We're checking to see if our metrics are improving or declining. We are making sure that we understand the information behind the metrics, because that can be a bit tricky also. Is this cycle an anomaly or not? So we're looking for trends over time. So now let's go to week 4. So here we are, week 4. And we'll go through our metrics again really quickly. So now we've executed up to 80% in this cycle. Our test success rate has improved to 91%. Our total number of open defects has gone down from 20 to 13 since the last time we did the chart. Failure rate has reduced from 10 to 5. So we found less defects this week. Code churn decreased from 50% to 30% in this build. Our code coverage increased from 40 to 60%. So now, based on that raw data, our ratings are now 3, 3, 5, 4, 1, and 4 based on that raw data, which translates to a total rating of 20. Now we have improved. We're in our yellow phase, so there's still moderate risk, and let's look at the spider chart. So if we see the spider chart, we can see that, yeah, there's still some blank spaces, but definitely not as much when we did this 2 weeks ago. So there's still a lot of caution in our project as we move forward, but we're getting better. We can see that total number of open defects is getting very good now. Failure rate is getting better, so a little risk there, but a lot better than it was before. Our code coverage is getting to a good percentage there. We still have a lot of risk in code churn, test completion, and test success rate. And the reason for that is, so we still got, there's still 13 open defects that are in this code. So there's still some changes that are going to need to be made in this application over the next several weeks, which is why there's still a lot of risk here, because wherever there's change, developers could break something that was previously fixed. So there's just a lot of opportunity for risk as we move forward. So now we're taking a snapshot, and for this presentation, we did snapshots at 6 weeks, 4 weeks, and then at 1 week. Obviously, we would be doing snapshots every single week so that we can see the progression as we move slower or closer to our ship date. So let's talk about week 1. So in week 1, we were able to execute 100% of our test cases. Our test success percentage, 99% of our test cases are passing. Total number of defects are still about 5 defects that are still in the application. Failure rate this cycle, we only found 2 defects this cycle. Very good. Our code churn, so between week 2 and week 1, only about 5% of the code changed between those builds, and then our code coverage got up to about 85%. So if we look at our raw data and how that translated to our ratings this week, we can see that we got 6, 5, and then 6 in every category, which gives us that total rating of 35, which based on our scale, that's almost perfect. So we're green, so you can see our spider chart has very little risk in it right now. Really just that area there, which is pretty minimal. And that's due to we've got a few outstanding defects that are still outstanding. And going back to a previous comment that I made, we could make this be about not just the total number of open defects, but we could start tracking these are high and critical defects. So just to make that, I'm sorry about that. So instead of tracking the total number of open defects, we could make this only track the high severity defects. But you would want to do that from the very beginning, meaning you wouldn't want this metric in week 6 to mean something different than week 1. So as you can see, as you were analyzing your spider chart week to week, you can see how the risk was tremendous in week 6. A lot of areas here. As we traversed to week 4, we got better, and then as we got to the end of that project, we really were able to minimize the project's risk was really minimized in all those areas. So this is just a week-by-week flow that you can look at that. Now, obviously, we're going pretty fast in this webinar. This is a part of a full-day course, and we can absolutely walk through lots of different scenarios in terms of how these metrics play off of one another. You may come up with, you may want to see a real-life scenario in terms of how the metrics would look in this case, and I will be perfectly willing to do that. So as we understand and manage the risk, we want to understand the relationship between the metrics so you can see how those metrics are affected by each other. You can learn to anticipate and minimize the risk before they happen, meaning if I know that if I can see I've got a large number of outstanding defects and my defect arrival rate is high, I know that my code turmoil or my code churn is going to be high the next week. So there's a tremendous amount of risk. I might want to do some additional regression. I know that that's affecting my test completion and coverage and success rate. I've got a note here, your test completion rate might be misleading without adequate code coverage. That's why you need more than just understanding the percentage of test cases that you've executed. You need to be tying that to either code coverage or requirements coverage. Because there could be a lot of, just because you've executed all of your planned test cases, that doesn't mean that your testing is adequate. I always want to know the information behind the data. So if let's say, here's one scenario, I might see my code turmoil or my code churn has increased 1 week, but I don't have any defects. So now I'm asking, so why did the developer go in and change all this code in the past week? And, that's actually a real case scenario. In this case, the developer didn't fix any defects. The developer waited until the end to add all of their comments. Still, still an element of risk, but at least we understood what that change was. So are you ready to release? Do you want to refine your release criteria now based on that individual and overall rating scale? Use those colors for presentation and effectiveness. People understand red, yellow, and green. So in many cases, as I am calculating those spider charts, I'm printing those out at my desk. So anybody that walks by, or you can have them printed out on the wall. Anybody that walks by, they can see exactly where we are with our application on that particular week. Let the data speak for itself. The data can speak for itself because we have come together as a team to determine what those ranges are. So you're not getting into debates as I don't think this is as bad as it seems. We got consensus at the very beginning of the project, and we determined what was going to be a 6 versus a 1. Some benefits. Combines the critical success factors in an easy way to interpret, gives a good indication of your product readiness as you get closer to your end date. It shows you some areas for risk quickly, and you can see how they can impact other areas of quality. And then it gives the management really a lot of good data to make some necessary risk assessments. Some gotchas. Got to gain buy-in early from your stakeholders around the metrics you're going to collect and the ranges. Got to have the information behind the numbers. Got to have repeatable processes around your test execution. Got to be documented and repeatable. Your test status has got to be consistent. Your configuration management, source control, repositories have got to be reliable and consistent. You want to allow for exceptions, and you might want to tweak some things as you go along. You're going to need some tools in order to do this. So from you have 3 categories. So you got your test management and defect tracking tools. You got, and the purpose is requirements traceability, test case creation, test status, defect management. Your source control. You need a good source control tool so that you can monitor the code churn or the code change between build cycles and prints. And then code coverage. You need a code coverage tool in order to capture the lines of code that have been covered while executing your manual or automated scripts. Remember, if you don't have code coverage, a code coverage tool, you can substitute your requirements coverage for that metric. Must you use all of these metrics? You don't have to, but I would say that there's no reason why you should not be able to track at least the 4 core metrics, and that was test completion, test success, defect arrival, and total number of defects. You don't need any tool in order to track that. You can do that using Excel, Word, or what have you. Keys to success, you want to keep it simple, communicate it early and often, be flexible, understand and manage the risk before they manage you. Make sure that from a management perspective, the metrics aren't used in the wrong way, as they can be demotivating instead of helping us manage risk better as a team. Use the metrics to help guide the team and not punish the team for bad metrics. With that, I will turn it back over to Eric Coleman.
Sorry, Michael, I had a little problem there with my microphone. Thank you very much. I want to give people the opportunity to ask some questions at this point. If anyone does have any questions, please feel free to submit them at your GoToWebinar window. Just while we're waiting, Michael, typically, what are some of the questions that you get when giving this presentation?
So a couple of them are, and I was trying to answer a few of them. What if you don't have the tools in place to track or measure all of those metrics? Are there some key ones that you can measure and still be effective? And as I mentioned, the answer is yes. For those metrics, you don't need any tool set in place in order to measure. And you can start to do this little bit by little bit. Another typical question is, again, if you don't have a code coverage tool, what are some other metrics that you can look at that might give you the same type of coverage or similar? You can measure your requirements coverage instead of code coverage if you don't have that tool. Some other type of questions. Should this replace your exit criteria? I'm not suggesting that it replaces your exit criteria. It can definitely be used as a guideline and really determine and show the risk that's still outstanding in the project from week to week as you get closer to closer. Some of the metrics are cumulative over those weeks. Some of those metrics are just for what happened that week. You'll need to determine that based on the type of development model that you're using, whether you're going waterfall or you're going agile. Obviously, from an agile, if you're using this in an agile world, it's not going to be cumulative. Every metric, you're starting from scratch for each sprint or each iteration. As opposed to waterfall, some of your metrics might be cumulative from week to week, such as your test percentage, passing rate, or completion rate. Other metrics are going to be just that week. Your defect arrival rate is not cumulative. That's going to be a week-by-week metric. Your code turmoil is a week-by-week metric. Your code coverage is a cumulative metric, as well as the total number of open defects. So I would say those are the key questions that normally come out of this.
Great. Looks like we do have a question or two here if you want to take a look at the question panel.
Yes, so I'll read it. What possibility is there that we can use or spend resources to generate these metrics to a small-sized company? The metrics are very easy to, the metrics don't take much time at all in order to generate once you have the template. And as a part of our course or additional follow-up, you can send me an email. I can definitely provide that template to you for use. So not an issue there. Code coverage tool. The code coverage of code for that release, yes. So there are codes or tools such as Biometrics that you can use in order to track the number of test cases. Well, it's tracking the number of lines of code, pass and decisions of code that your test suite has hit for that particular cycle. Hopefully I answered that, Marina. If not, definitely send me an email. I can provide more information. Third question, what if a vendor is building your application? Will the vendor have these tools to provide this information to the test lead? They may or may not have the code turmoil and code coverage tools, as I mentioned, but they should absolutely be able to provide those other metrics. Test complete, test passing, defects found that week, and total number of open defects, and even requirements, and even the requirements coverage percentage. Great questions. Thank you, folks.
Thank you, Mike, for your time today, and thank you to everyone for joining us for today's webinar sponsored by IIST, the leaders in education-based certifications and training. For more information on how IIST can help you or your organization, please visit www.iist.org. You can follow IIST on Facebook, Twitter, LinkedIn, and YouTube to find out more about IIST news, events, and promotions. Thank you all again for joining us today, and have a great day.